Hi guys, welcome to the video, and today we are focusing on calculation for the conservation of linear momentum. So a quick recap on the definition for the conservation of linear momentum. It goes like this. The total linear momentum of an isolated system remains constant or is conserved, right? So let me tell you what this means. Basically, this means that the total momentum of this system is the same before and after the collision. Because this is a collision, the balls were going towards each other at first, but they were now going away from each other at the very last moment. So yeah, this is a collision. They collided and then they separated, right? So basically what the conservation of linear momentum means, it means that the total momentum of the two balls is the same before and after the collision, right? So yeah, I hope we are good. So usually they tell us that we should find the velocity of one of the objects after the collision, or maybe sometimes they tell us to find the velocity of one of the objects before the collision, but they don't make it two velocities. It's usually one. So yeah, I'm gonna shut up now because we should get to the calculations. So we have ball 1, which is 1.5 kg in mass, and it has a velocity of 1.5 meters per second to the right. Ball 2, 1 kg, and it's traveling at a velocity of 2 meters per second to the left. So now for the 1.5 kg, it is traveling at 1.2 meters per second to the left. And lastly, the 1 kg ball has an unknown velocity. So this is where we use the conservation of linear momentum. All right, so we go to the formula. It goes like this. The sum of the momentum before is equal to the sum of the momentum after. Yeah. So for you to work this out, you need to remember the formula for the momentum. And momentum has a formula that say P is equal to mv. So yeah, because we are calculating the sum of the two momentums, then it's obvious that we are going to say mv plus mv. So mv for the 1.5 kg ball and mv for the 1 kg ball. So it is now going to be something like this. mv plus mv, right? So this is where you need to specify that you are talking about which ball, right? So I've decided to call the 1.5 kg ball A, right? So we are going to have something like this: A, B, and this one is A again, and this one is B. We are gonna say the mass of A and the velocity of A initial. So now it is the mass of B and the velocity of B initial before the collision, right? So you continue. You now say the mass of A and the velocity of A at the final moment after the collision, right? So now we are also working out the mass of B and the velocity of B at the final moment. All right, we are supposed to choose the direction as positive, so I'm simply going to say to the right as positive. This is how I'm gonna work it out. All right, so I want you to see when I fill in, I want you to understand very well how I got these values, right? So usually how I do this is I say that the mass of A is 1.5 kg, but where is it going? To the right. Well, we chose to the right as positive, so it's going to be positive. So it's going to be 1.5. I'm sorry for that. 1.5 into 1.5. I don't know who taught me this. These are like, right? So now the mass of B is 1 kg. So we are multiplying the 1 kg into 2 meters per second. That is going to the left. So it is going to be negative because it's going to the left. So it's minus 2. It's equal to, let us see, 1.5 kg ball. I don't know who taught me this, right? 1.5 kg ball, and it has a velocity of 1.2, right? So now we are adding it with the ball that has a mass of 1 kg. Wait. This was supposed to be negative. Please remember this is negative, right? Because it's going to the left. You see this, it's going to the left, and we chose to the right as positive, right? So now we have this one, v. We are going to call this v because we don't know the velocity, right? We're going to say this is v final for the b ball, vb final, yeah, right? So now we work things out. 2.25 plus -2, right? And this is equal to -1.8 plus velocity of b final, right? So now we can do the maths and see what we get. So 2.25 minus 2 plus 1.8, because I transposed this, is equal to the velocity of b final. So let us calculate the velocity of b final. So the velocity of b final is 2.05, right?